My name is Ryan Dillon. My project is to create an automated plant monitor system. It is a system that monitors the pH and water level of hydroponic plants to maintain and research them in order to create better produce. This is basically what my slides are going to look like here. My motivation for choosing to do this project is that I'm intensely interested in hydroponics and the science of horticulture. Hydroponics helps to solve the issues of environmental sustainability, water conservation. 80 to 90% of all potable water goes to agriculture. It solves land management, sustainable food production. Hydroponics and aquaponics are both rapidly growing industries that benefit greatly from the exponential growth of technology. Agriculture is a colossal part of the U.S. economy, and there are incentives on all sides to research and improve the system of hydroponics. On the next slide, I put a really good study of monitoring the nutrients and pH with a hydroponic system and how that affected the growth and quality of cabbage growing in a controlled environment. So I should say this is not my data, but the study clearly shows different levels of nitrogen, how different levels of nitrogen in the nutrient solution significantly affects plant growth. With my plant monitor, you can control different variables and monitor, like the pH. It can tell you the nutrient levels and the water level, can control for that difference between the plants. And so you can understand how the growth of the plants and subsequently, how well they respond to different changes, and you can use that to optimize their growth. So in this here, you can see the control is 0 to 100 ratio of NH4 and NO3, and then T1 to 90, so on. And so you can clearly see the EC value is the electrical conductivity that comes from the pH meter, and that's measuring the nutrient solution. So you can basically see how these growth rates are, like, they're significantly affected by these different ratios. For example, let's say Kevin, it's like a user scenario. Let's say somebody wants to purchase the biggest, sweetest watermelons on the market, and you're willing to pay a significant premium, like maybe, instead of $5, it might be like $60, and it's grown in a more controlled environment, or, you want to improve your company's hydroponic growing process, or, so on. So I listed my requirements to be, I'm going to use a parts per million electrical conductivity meter to check the strength of nutrient solution in the water by measuring total dissolved solids. These are vital to measure the nutrients in the water, and they're often the cheapest option. And it's important to measure this because they require a huge amount of nitrogen, phosphorus, potassium, calcium in the water. And different plants might want more acidic or alkaline water. And then I'm also going to use an Arduino with an ultrasonic sensor to measure the water level in the container with the plants every hour. And then of course, the water level is very important because there's, the plant can drown, the parts of the roots actually need oxygen. And then I'm going to connect both of those to a laptop to receive the data, and then send that data basically by email to alert me if there's anything wrong, or just different, like some status of the system. So also, connect a mechanical outlet timer to the light so the plants will be able to receive some time to rest. Connect the Arduino measuring water level and nutrient content in the water to a computer running a program. Like I said, that will send alerts with an email to you. And then have a kind of structured program that will keep track of the data on the computer, keep track of when you planted the seeds, when you need to change the nutrient solution, switch from grow to bloom solutions. Because plants need more of certain nutrients during different phases of their growth cycle. Like, they might need more nitrogen during the vegetative stage. And so you'd use the grow versus the bloom. So this is my architecture diagram for a prototype. It's pretty self-explanatory for the most part. I think you measure the water level with an ultrasonic sensor connected to an Arduino, connected to a laptop. You have a ppm meter connected to either the Arduino or the laptop, and you have that either continuously or or you have a device that takes it in and out of the water every so often, and you measure the electrical conductivity to measure the nutrients in the water. And for this part, I'm not exactly sure how I'm going to make Java send an email. They've changed things recently, so it's harder to send emails with Java, but I think you could probably do it with AWS Lambda. You could just send an alert or something if something's wrong. You don't want to be getting an email every single hour. And then I have like a preliminary bill of materials, with the different nutrient solutions and the different things to put the seeds in. And I don't have any videos or demonstrations, unfortunately, because I've just been under kind of a time crunch. And same goes for user feedback and test results. I switched this project only a few weeks ago, and I haven't really had enough time to prototype and collect those items. So in conclusion, even though my project implementation was set back significantly, I am very motivated to create the actual prototype for this system. I intend to continue working on this over the summer. I have some parts of it already, but and I will need to research more about how, what is the best way Java can send email notifications, and I'm sure that's probably not going to take that much time. And then beyond that, probably maintaining the system on the laptop is going to take some time, and I might need to have a server do that as well. I'll have to see. That's it.